Trigonometric equations. Today we're going to be solving linear and quadratic trigonometric equations. If you'll recall, when solving linear equations, you isolate the variable. And when solving quadratic equations, there are 4 different methods that you can use, but let's focus on factoring or the square root method. We can apply these same methods when we're dealing with trigonometric equations. The steps for solving trigonometric equations are as follows. First, decide whether the equation is linear or quadratic. If it's linear, then isolate the variable, and if it's quadratic, then decide whether to factor or use the square root method. If the equation has more than one trig function, then see if one of them can be factored out or use substitution with identities to rewrite it in terms of one trig function. Solve each equation for exact solutions over the interval from 0 to 2 pi. This first equation is a linear equation because the highest power is 1, so we need to isolate the variable. In order to do that, I'm going to first subtract 1 from both sides of the equation. And this gives me 2 cotangent of x is equal to negative 2. And then I'm going to divide both sides by 2. And I have the cotangent of x is equal to negative 1. Well, cotangent is connected to the x, and so to get the cotangent off of x, we're going to take the cotangent inverse, because the inverse of cotangent, that's the inverse of the trig function, and inverses undo each other. Inverse operations such as multiplication and division undo each other. Addition and subtraction undo each other. So in trig functions, the function and its inverse will undo each other. So if I take the cotangent inverse of both sides of the equation, this will allow me to isolate the x because, as I said, cotangent and cotangent inverse undo each other. So I have x equals cotangent inverse of negative 1. So now I need to state which values or which angles have a value, which angles of cotangent have a value of negative 1 between the interval from 0 to 2 pi. And those would be 3 pi over 4 and 7 pi over 4. So the angles in radians whose cotangent are negative 1 between 0 and 2 pi are 3 pi over 4 and 7 pi over 4. Okay, so now let's look at b. Again, this is a linear equation, so I need to isolate x. So my first step is to subtract 3 from both sides. And that gives me 2 times the sine of x is equal to 1. Then I'm going to divide both sides by 2. And I have the sine of x is equal to 1/2. Now to isolate x, I'm going to take sine inverse of both sides. And that gives me x is equal to sine inverse of 1/2. So the solution set, or the angle whose sine or sine inverse of 1/2 would be pi over 6 and 5 pi over 6. This next equation is quadratic because if you'll notice, this trig function is squared. And so if we have a square as our highest power, then it's a quadratic function. So if it's a quadratic equation or a quadratic trig function, we're either going to factor or use a square root method. Well, we can't use the square root method because we have this linear term, so we're going to have to factor this equation. All right, to factor, everything needs to be on one side equal to 0, and then this is a trinomial, so we know that trinomials factor into two binomials. The square root, so we're going backwards from FOILing. So if I were to take the square root of cosine squared of x, I would get cosine of x times the cosine of x. The only factors of 1 are 1 and 1. This tells me that my signs are the same, and this tells me what they are. They're both positive. So if I put pluses in both spots, this is the factored version of this trigonometric equation. Okay, so once it's factored, we want to set each factor equal to 0 and solve. All right, so I have cosine of x plus 1 equals 0. And we have the same factor over here. So if I solve this, I'm going to subtract 1 from both sides, and I get cosine of x equals -1. And then if I take the inverse of both sides, I would get x is equal to cosine inverse of -1. Of course, this would give me the same answer, so I don't need to do it twice. So the solution set would be the angle whose cosine is -1. Again, we're in the interval between 0 and 2 pi, and that would be at pi. Okay, for D, we have another quadratic function because we see that tangent squared. But this, instead of factoring, we would use the square root method. So if you'll remember, the square root method says that we need to get whatever is being squared by itself. So this is what's being squared. To isolate it, we're going to subtract 3 from both sides. And I get tangent squared x equals -3. And then we take the square root of both sides, which would take the square off the tangent, and I get tangent of x, but tangent of x is equal to plus or minus the square root of -3. Well, that's an imaginary answer. So we're looking for real number answers, so this would just be no solution. Okay, we're going to continue to do some more trigonometric equations, but this time we're solving equations for exact solutions over the interval between 0 and 360 degrees. So we're in degrees and not radians now. If I look at this trig function, I see that it is quadratic because I have a tangent squared. So what I want to do here, since I see two different trig functions, is I want to see if I can factor out a greatest common factor. And I can. I have these two terms. This is a term and this is a term. And the greatest common factor between those two terms is tangent squared theta. So if I factor out tangent squared theta, I'm left with 2 times the sine of theta minus 1 equals 0. Now, there's nothing else I can do with either of those two terms. I have tangent squared theta, and then I have 2 sine theta minus 1. That's completely factored. So once it's completely factored, I take each factor and set it equal to 0. So I have tangent squared theta equals 0, and I have 2 sine of theta minus 1 equals 0. For the tangent squared theta equals 0, I'm going to take the square root of both sides. Of course, there's no plus or minus 0. So I would get tangent of theta equals 0. and then I take tangent inverse of both sides. So I would get 0 is equal to tangent inverse of 0. So I want to know where tangent is 0 between 0 and 360 degrees. And that would be at 0 and at 180 degrees. Of course, tangent is also 0 at 360 degrees, but if you'll notice, this interval does not include 360 degrees. It's got that parenthesis, so that means it goes up to 360 degrees, but 360 degrees is not included. So that's why we just list 0 and 180 degrees. Okay, and then for 2 sine theta minus 1, I need to solve for theta. So I'm going to add 1 to both sides. And I get 2 sine of theta equals 1. Divide both sides by 2. And I have sine of theta equals 1/2. I take the sine inverse of both sides, and I get theta is equal to sine inverse of 1/2. Okay, so sine, the angles where sine is 1/2 is at 30 degrees and 150 degrees. So we should list our solution set for this trigonometric equation as one solution set. So it would be at 0 degrees, 30 degrees, 150 degrees, and 180 degrees. And that would be the solution set for this trigonometric equation. Here we have 2 sine of theta minus 1 is equal to cosecant. Well, in order to solve this, even though this looks like a linear equation, there's 2 different trig functions. So we can't just isolate the variable. So let's first get everything over to one side of the equation. So I'm going to subtract cosecant of theta from both sides of the equation. So I get 2 times the sine of theta minus 1 minus cosecant of theta equals 0. Okay, so if I look at this, I have sine, I have 1, and I have cosecant. Well, I can't factor out a greatest common factor, so let's think about what we can do. Well, I know that cosecant is related to sine because it's the reciprocal of sine. So if I multiply everything times sine, that's going to get rid of that cosecant. So let's do that. Let's multiply everything in the equation times sine of theta. Okay, so if I do that, if I multiply sine of theta times 2 sine of theta, that gives me 2 sine squared theta. If I multiply sine of theta times negative 1, that gives me a negative sine of theta. And if I multiply sine of theta times its reciprocal, cosecant, that's just going to give me a negative 1 equals 0. So now I have a single trig function. This is a quadratic equation. It's a trinomial. So I'm going to factor this trinomial. Alright, so I'm going to have 2 sets of parentheses. And I'm going to create 2 binomials. So if I think about what I can multiply to get 2 sine squared theta, I would multiply 2 sine of theta times the sine of theta. The only factors of 1 are 1 and 1, so I know that has to go in these 2 spots. And then my second sign is negative, so I know that the signs in my binomials are going to be different. And I know that since my middle term is negative, my biggest product also has to be negative. So that would be negative, and that would be positive, equals 0. Okay, so now I have completely factored my trinomial, and I'm going to take each factor and set it equal to 0 and solve. Okay, so I'm going to subtract 1, and I have 2 sine of theta equals negative 1, divide by 2. That gives me sine of theta equals negative 1/2, and then I take the sine inverse, so I get sine inverse is equal to, theta is equal to sine inverse of negative 1/2. And then for the other factor, I'm going to add 1. I get sine of theta is equal to 1. Take the sine inverse, so theta is equal to sine inverse of 1. Okay, so the angles whose sine are negative 1/2 and positive 1, well, sine is, at 1, sine is 90 degrees. And then sine is negative 1/2 at 210 degrees and 330 degrees. Okay, for this last example, we have cosecant squared theta minus 2 times cotangent of theta equals 0. Okay, so again, we have two different trig functions. We can't factor a common factor out. So let's see what we can do here. Cosecant is not the reciprocal of cotangent, so we can't do what we did in the last one and multiply by a trig function to change them all to the same trig function. So if I try to think about how I can possibly relate cosecant and cotangent, there's the Pythagorean identity that relates cosecant and cotangent. We have a Pythagorean identity that says 1 plus cotangent squared theta is equal to cosecant squared theta. So I'm going to replace cosecant squared theta with that based on the identity. So I'm replacing cosecant squared theta with 1 plus cotangent squared theta. Minus 2 cotangent of theta equals 0. Okay, so now I have a trinomial again, 1 plus cotangent squared theta minus 2 cotangent squared theta. So let me put it in descending order. Okay, so that would be cotangent squared theta minus 2 cotangent of theta plus 1 equals 0. All right, so we have this trinomial. We're going to factor it into two binomials. And in my first two spots, I'm going to put cotangent of theta The only factors of 1 are 1 and 1. The second sign is plus, so that tells me my signs in my binomials are going to be the same. But my first sign is negative, so I know they're both going to be minus. Okay, so since they're the same, I'm just going to take one of them and set it equal to 0 and solve. Cotangent of theta minus 1 equals 0. I'm going to add 1 to both sides. Alright, so I have cotangent of theta equals 1. I take cotangent inverse of both sides, and that gives me theta is equal to cotangent inverse of 1. And the angles where cotangent is 1 are 45 degrees and 225 degrees. And that's my solution.